This lesson is about angular and linear speed. Angular speed is how fast an angle changes, like how fast the inside of a circle is opening up, and the formula for angular speed is theta over time. Remember, you've got to keep theta in radians. So if you're given a degree, then you must take the degree and multiply it by pi over 180 in order to convert that into a radian. And of course, T stands for time. And when you think about it, it's pretty easy to remember this formula, because if you think about a typical rate of speed formula, distance equals rate times time. And if you solved for rate, you'd get distance over time. And the distance that we're discussing right now is the distance that an angle opens, which is theta. Okay, let's do an example. If a blade rotates at 2400 RPMs, A, find the angle speed per minute, and B, find the angle speed per second. It's really easy. So angular speed equals theta. Well, this thing is rotating 2400 rotations per minute. So one full rotation around a circle is how many radians? One full rotation would be 2 pi radians. But how many times are they rotating around this circle? It says that the rotation happens 2400 times in this time frame. So theta is 2400 times 2 pi. All over your time, it says it's in speed per minute, so that's in 1 minute. Now I know that's it can be a little confusing about where the 2 pi come from, but again, theta is how far something has opened up within this circular path. This particular theta rotated 2400 complete times around a circle. Well, one complete rotation around a circle is 2 pi, or 360 degrees. And we went around that circle 2400 times, or opened up theta 2400 times. So that's where those numbers came from. And then you just multiply this out. So that's 4800 pi per minute, because it's just one. And again, a technician is not going to say, yeah, your tire's rotating at 4800 pi per minute. That just isn't the way we speak. So you, in your calculator, would put 4800 times 3.14 for pi, and you'd get 15,072 per minute. That's your angular speed of this blade. How about if I wanted per second? So I think in this lesson, the hardest thing is just changing the measurements. If I've got 15,072 in 1 minute, and I want to change minutes to seconds. Well, a lot of you can use common sense on how to change a minute to a second. Some of us don't have common sense. So for myself, I like formulas, and I really like the way in science or stoichiometry, don't groan at that, it's awesome. They set up this little chart to help you know when to multiply and when to divide, because that's where I get confused. When do I multiply by 60? When do I divide by 60? I don't really know. So I do know that I want to end up with my seconds. So I need this 1 minute to disappear. I need that to go away. Well, in order for that to go away, for something on the bottom to cancel with something else completely, then that other thing has to be on top. So minutes must be on top and seconds must be on bottom. And I know that 1 minute is 60 seconds. So then look and see what happens. When you multiply straight across, this on bottom cancels with this on top, right? And up top, when you multiply straight across, I get 15,072 times 1 is just 15,072. On bottom, 1 times 60 is 60, and the only word that is left is seconds. And then when you put that in your calculator, you get 251.2 per second. There you go. That's angular speed. Let's talk a little bit about linear speed. Linear speed is how fast an object is traveling, and typically they're talking about a linear distance. Thankfully for us, arc length is considered a linear distance. Even though it's a circular path, if you took a piece of string and laid it around that circular path, because we're talking about the circumference of the circle, that's your arc length, is a portion of the circumference. And if you were to lay a string around that and cut it in the exact amount of where it traveled, you could then take that string and lay it out in a straight line. So linear distance equals rate times time. Y'all know this. If you took distance equals rate times time, and we want to know a rate of speed, then all you have to do is solve for r. So divide both sides by time, because I'm trying to get r by itself, and rate of speed equals distance over time. We've already discussed the distance around a circle. That's called arc length. The distance traveled around a circle is the arc length, and that's arc length over time. Arc length is radius times theta. So linear speed of an object traveling in a circular path, I'm going to say that one more time, linear speed of something that's traveling in a circular path, for example, a nail stuck in your tire, equals radius times theta over time. And again, keep in mind that theta has to be in radians. So here's your formula for linear speed. Let's stick with the example that we had for angular speed, where it's traveling or rotating 2400 RPMs. And you're told that this blade that's rotating has a radius of 4 inches. So our linear speed would be radius, so that's 4 inches, times theta. Well, again, this thing is traveling 2400 rotations, and one rotation is 2 pi. I'm not doing one rotation around the circle, I'm doing 2400 rotations around the circle. And our time, it said per minute, so that's 1 minute. If you do the math on this, 4 times 2 times pi times 2400, all of that in your calculator, you get 60,288, and that's in terms of inches per 1 minute. Most real world problems are not in inches per minute. Most real world problems are in miles per hour. So let's convert. Stick with me. Pause, go back, listen to those instructions again if you need to. But now we're going to convert these to miles per hour. So I'm going to take my 60,288 inches and 1 minute, and I'm going to convert that to miles per hour. So here's what I'm going to do. I'm going to show you the conversion all along the way. If you have a different way that you like to convert, then go right ahead. Like I said, if you've got that common sense, use it. I just don't have it, and so I like to see where my conversions come from. I know I want to change inches, so I'm going to deal with my inches first. I need inches to go away, so I'm going to put that on the bottom so that they will cancel top to bottom. I know that inches can convert to feet. If I can get that to change. Okay, but I don't want to stick with feet. That's not what I need to do. I want to end up with miles. So let's change feet now. So feet would disappear if I put that on the bottom. And feet I can convert to miles. And that's where I want to land. So that will work. So I know that 1 foot is 12 inches. And I know that 1 mile is 5,280 feet. Now let's deal with our minutes. Minutes is on the bottom. I'm going to want that to cancel away, so I'm going to put minutes up top, and I want to convert that to hours. So I know that 1 hour is 60 minutes. Now let's just do the math. Inches, the word inches and the word inches reduce. The word feet and the word feet reduce. Minutes on bottom and minutes on top reduce. Now let's multiply all. We're going to multiply. So you're multiplying all the way across the top and you're multiplying all the way across the bottom. I'm going to have to scoot this over so you can see it. 3,617,280, and the only word left up top is miles. And on bottom, 1 times 12 times 5280 is 63,360. And the only word on bottom is hours, so we are in miles per hour. And when you reduce that down, you get 57.1 miles per hour. So if a nail were stuck in a 4-inch radius tire, maybe a lawnmower, I don't know, and it's rotating theta 2400 RPMs, then that nail is traveling 57 miles per hour around the circle. And that's how it's done.